Okay, so the next video is all about Ohm's Law. So Ohm's Law says that resistance is constant. So that means that my R value is not changing. From that, we can then say that voltage is proportional to current. Okay, now this little symbol here represents proportional. Okay, so we're saying that V and I are proportional. Okay, so if I was to plot this as a graph, we usually plot this as an IV graph because we've been changing the voltage, measuring the current. Okay, so if you've been doing an experiment for looking at this, you're trying to see, for example, if it obeys Ohm's law. So if you see that you get a straight line gradient when you plot V and I against each other, if you get a straight line gradient going through the origin, this is the shape that shows that it obeys Ohm's law. Okay, so this would be an ohmic conductor, this graph. So when we're looking at this, we can show that this is obeying Ohm's law because we can show that resistance is constant. So if we remember the equation, V is equal to IR, so I over V is equal to, if I look at this, I divided by V, that's equal to 1 divided by R. Okay, that actually in this case is my gradient because I divided by V, that's my change in Y over my change in X. Okay, so my gradient is equal to 1 over resistance. Okay, so if I have a constant gradient, that means 1 over R is constant, okay, and therefore, okay, resistance is constant. Okay, so we can see that resistance is constant because we have a constant gradient, because this is our change in I over our change in voltage, okay, which equals, in this case, if I do my change in I over my change in V, that gives me my 1 over R. Okay, so that is the gradient. All right, so an ohmic conductor, resistance is constant, voltage is proportional to current, so I'd get a straight line graph if I plot I against V. Okay, so some examples of things that obey this, okay, something like a fixed resistor. So if I have a circuit with a fixed resistor in that, okay, that's going to give me this characteristic of graph, okay, so it obeys Ohm's law. We also can talk about wires if we were measuring the resistance of a wire and we kept the wire at a constant temperature. Okay, again, if we change the temperature, we can change the resistance. So that's really important that we remember to say that at a constant temperature there. Again, if you want to know about why, there's a little video about factors that affect resistance. So some examples of ohmic conductors would be a fixed resistor or a wire at a constant temperature. So again, because they keep the resistance constant. Okay. On the other side then, we can have objects that do not obey Ohm's laws, and we call those non-ohmic conductors. So a non-ohmic conductor does not obey Ohm's law. And what that means is it means the resistance is not constant. It means the resistance is changing. So voltage is not proportional to I. Okay, so often they ask us to learn or explain this, and we often have to maybe recognise this from experiments looking at our IV characteristics. So, for example, you might have done an experiment looking at the light bulb and trying to see about your resistance for that. So if you did if you got a shape when you did your IV graph that wasn't nice and straight and linear, but you got it curving, okay, you got it being changing with your gradient, that means it's a non-ohmic conductor. So for an IV graph that has a curving gradient, a non-linear gradient, okay, that means it does not obey Ohm's law, okay, because R is changing, okay. So R is changing because remember 1 over R is equal to the gradient. And since the gradient changes, that means R is changing. Okay, so if you can see here, if I kind of use my ruler, the gradient is always changing as we go through. Okay, so my R value is always going to be changing through this circuit. Okay, so resistance is not constant, it's changing. V is not proportional to I, it does not obey Ohm's law. Okay, so for example, so some different examples of different types of non-ohmic conductor. So the main one that we have used in class is the filament light bulb. So remember the filament bulb, okay, it's made with that filament inside the light bulb, and as we go through that light, that wire heats up, okay, which means that we're getting a changing resistance. Or if I had wires at changing temperatures, so if I left that wire on and let that wire heat up, okay, it's going to stop being ohmic and start becoming non-ohmic. So wires at a changing temperature as well are examples of non-ohmic conductors. And if we were doing an experiment for this, so we wanted to look at calculating or trying to see if something was an ohmic conductor or a non-ohmic conductor, okay, you're going to simply have your circuit, you would have your ammeter in, okay, and you would have your device. So for example, you could have your light bulb or you could have your resistor. I'm just going to draw in a resistor, but it could have, instead of being a resistor, you could have had a light bulb. You could have just used a wire. You would always want to measure your voltage across your components. Your voltmeter goes across in parallel. And so you would be then changing your voltage on your power supply. You would measure your V from here, you'd measure your I from there. You'd do that multiple times, and then you would plot the graph and see what type of curve do you get. If it's curving, it's non-ohmic. If it's a nice straight line, it would be ohmic. Okay, so as you would do this, if you were measuring this, you would then change and measure your ammeter reading, and you would measure your voltmeter reading each time, and then you would see if it's ohmic or non-ohmic.